Distance Learning 8.6 Volume of Pyramids and Cones. The help video. So volume of a pyramid, volume equals base times height over 3. Base always means the area of the base. So in this case, the area is a rectangle. So our base area is going to be 4 times 3. The true height, or the altitude here, is 5 over 3. That reduces, so we simply get 20 inches cubed. Question number 2. Find the volume of a cone with a base radius of 6 yards and a true height or altitude of 12 yards. Write it in exact terms of pi. Once again, volume equals of a cone, base times height over 3. Your base here is a circle. Circle is pi r squared. So 6 squared times pi times our height, which is 12 over 3. Take the 3 into the 12, or you could have taken the 3 into the 36. It doesn't matter, but you end up with 36 times 4. So our volume here is 144 pi yards cubed. And you leave it at that because it says in exact pi form. Again, we're finding the volume in exact terms of pi. Our base here, this time we're given the diameter, so we first have to find our radius, which would be 3. So our base is pi r squared, so it's pi 3 squared times our height, which is 11 over 3. This is pi 3 times 11 over 3. The 3's cancel, so the volume here is simply 33 pi yards cubed. The rectangular prism and the rectangular pyramid are shown have the same length, width, and height. So we're going to find the volume of the prism first. Volume of the prism is base, which is 6 times 5. So our base is 30 times our height, which is 4. So the volume of the prism is 120 yards cubed. Volume of the pyramid is base, same length and width. So our base is still 30. Our height is 4. But the volume of a pyramid is base times height over 3. Therefore, it's 120 divided by 3. So it is 40. So in comparison, the pyramid is 1/3 of the prism. The pyramid is 1/3 of the prism with the same length, width, and height. And you read these questions, the equation is true for all rectangular prisms. The equation is true only for rectangular prisms and rectangular pyramids shown above. The equation is true for rectangular prisms and rectangular pyramids with the same length, width, and height. Only that last one is true. The reason why we have the exact 1/3 ratio is the length, width, and the height is the same. The cylinder and the cone have equal heights. Find the volume of the cone. The volume of the cone is base times height. So we have here if you're wondering whether that 12 is the radius or the diameter, look very, very carefully. That is 12 centimeters squared, so it's not a singular length. This 12 centimeters squared is the base. So for a cone, it's base times height over 3. So 12 times 7 over 3. And the volume of this cone is going to be 28. We're assuming pi is already folded in, so it's going to be 28 centimeters cubed. Cylinder's just base times height, so that's 12 times 7. So we get 84 centimeters cubed. 3 of these go in one of those. So the volume of the cone is 1/3 of the cylinder. Equation is true for all cylinders and cones with congruent bases and equal heights. A trucking company needs to move a pile of limestone. The limestone is stored in the shape of a cone. The pile is 13 yards high. And the base has a diameter of 18 yards. How many truckloads will the company need if each truck holds 7.02 yards cubed? We're going to use 3.14 for pi. So volume equals base times height. Once again, the base is not 18 here. The base is a circle, which is radius squared times pi. So 9 squared times pi times our height, which is 13. We're supposed to use 3.14 for pi exactly. So this was 9 times 9 times 13 times 3.14, and then it's divided by 3 because it's base times height over 3. So we get 1,102.14. 1,000 0.14. So each pile, yards cubed, we're going to divide by 7.02. And we get exactly 157 truckloads will it take to move that pile.